Let's go over this quiz. Number 1. The secant of negative 7 pi thirds. What I would do is divide the entire unit circle into pi thirds. Whoops. Pi thirds radians sized wedges. So notice there's 6 total. That black y-axis does not count. And then I want to count 7 of them in the clockwise direction. So 1. Whoa! 1, 2, 3, 4, 5, 6, 7. So if I think of a triangle in this unit circle here, that's the really short base but really long height. So that y-coordinate, the x-coordinate has to be positive 1/2, and the y-coordinate a negative radical 3/2. So the secant is the reciprocal of cosine. It's the reciprocal of the x-coordinate. The reciprocal of 1/2 is 2. Okay? To figure out the coordinates, you either have a short, tall triangle, a equal width and height triangle, or a long, short triangle. And that's really how my brain works. I picture, is it the short, tall one? If that's the case, that's a 1/2 for the x, radical 3/2 for the y, and then I pick negative or positive based on what quadrant it's in. Is it the equal, like 45, and it's radical 2/2, radical 2/2, or is it the long, radical 3/2 x coordinate, short 1/2 y coordinate triangle? Okay?
Wait, question.
Yes.
You're separating them in the already 30 degrees. Wouldn't that make it not? Never mind. Never mind.
Okay, let's go on to number 2. 270 degrees. Thought this one would go a lot better than it did. 270, you don't even need to count. You should just know that's this one down here, and that has coordinate 0, -1. Tangent is the y-coordinate divided by the x. -1 divided by 0 is undefined. Okay. Next, number 3. Okay. Seeing a substantial number of mistakes, particularly with how the triangles are being drawn, you're told that sine of theta is 2/3, so that's positive, so that's either quadrant 1 or 2. But you're also told cosine is positive, so the only quadrant with which sine and cosine are both positive is quadrant 1. So you're going to have a quadrant 1 triangle that looks like this, where this angle right here is your reference angle. So since sine of that angle is 2/3, I can call the opposite side 2, the hypotenuse 3. The Pythagorean theorem, the square root of 3 squared minus 2 squared, gives me radical 5 for the other side. So sine of this angle is 2/3. I had a lot of people who drew the triangle wrong, and so they gave me sine was like radical, or 2 over radical 13, which I thought was interesting because that totally contradicted what the problem gave me. So sine is 2/3, cosine is going to be radical 5/3, and tangent is 2 over radical 5, and I did not need you to rationalize that denominator. So then cosecant was 3/2, secant was 3 over radical 5, and cotangent radical 5 over 2. Okay? Agreed. Any questions on that one? No? Good. Alright, number 4. I had a lot of people just like taking these coordinates and saying cosine's -1, sine is 8, and going from there. One, we've already talked sine and cosine cannot output anything larger than 1 or less than -1. So a sine value equal to 8 is just crazy talk. And plus, that would be true if that point was on the unit circle, meaning its distance from the origin was what? 1. Clearly, by common sense, the point -1, 8 is much farther than 1 from the unit circle, right? Agreed? Okay, surprising number of people that did that. First of all, what quadrant is the point -1, 8 in? It's in the quadrant 2, so I'm going to draw a quadrant 2 reference triangle that looks like this. Now let me show you what a lot of people did by mistake. A lot of people plotted the point negative 1, 8. Let's pretend it's right here. And then they drew this triangle. And so they labeled this negative 1, they labeled this positive 8, which is all correct. And then the Pythagorean theorem, 64 plus 1 is 65. They call the hypotenuse radical 65. The problem is they then used this angle right here as the reference angle, which is wrong. If you're going to draw your triangle like that, which you shouldn't, this angle up here actually is your reference angle. Right? And so a lot of people, what you ended up doing was you ended up finding, you got all your co-functions backwards. You got for sine what you should have gotten for cosine, and vice versa. You got cosecant and secant switched, and you got tangent and cotangent switched, because you were using a complementary angle, so you got all the co-functions switched up. And it was primarily because you drew the triangle wrong. When you plot the point negative 1, 8, you should go with a triangle that looks like this. This is still negative 1, this is 8, and this is radical 65, but you can see your reference angle right here was that one. You could use the triangle drawn the other way, but by alternate interior angles, you would have used the wrong reference angle. Make sense? So now, the sine of this angle would be opposite over hypotenuse, 8 over radical 65, positive. The cosine is going to be a negative 1 over radical 65, and the tangent is going to be an 8 divided by negative 1, which is negative 8. A lot of people had correct answers, but not even close to simplified. Like, some people literally wrote the sine divided by the cosine. So I saw people writing 8 over radical 65 divided by negative 1 over radical 65 and leaving it like that. It's correct, but holy smokes, try and simplify your answer a little bit, especially when the answer is as easy as just negative 8, right? So then your cosecant is radical 65 eighths positive, your secant is a negative radical 65, and your cotangent is a negative 1/8. Oh, I forgot this. Okay? And then number 5 was probably one of the more missed problems, especially early in the day, not so much later in the day. But if you draw the line y equals 1/3 x, it's a line, it's not a ray, it's a line, you're going to end up with something that looks like this, right? So if this line represents the terminal side of some angle theta, your angle theta's terminal side is either in quadrant 1 or quadrant 3. We don't know which until we look at this part here. Not only is the terminal side on the line 1/3 x, sine of this angle happens to be negative. And where is sine negative? Quadrant 1 or quadrant 3? Quadrant 3. So your terminal side has to be over here. So there's what your reference triangle looks like. Because the slope is 1/3, that's rise over run, this has to be a negative 1, this has to be a negative 3. Pythagorean theorem tells you the hypotenuse is radical 10. Right? So your sine is negative 1 over radical 10. Your cosine is negative 3 over radical 10. And your tangent is a positive 1/3. Cosecant's a negative radical 10. Secant's a negative radical 10 over 3. And cotangent is 3. Any questions on number 5?
How did you, calculate on
Basically, I was looking for, clearly you could have gotten one minor mistake could have made you get all 6 trig functions wrong. Right? So I thought about making it a 6-point problem because there's 6 trig functions, but that didn't seem fair because I made it a 4-point problem. Everything is 4 points except the first 2. I made 2 points apiece. So the first 2 problems on the quiz are essentially one 4-point problem combined. So I weighted those smaller. So this is a 4-point problem. It was kind of like, what mistakes did you make? Did you just draw your reference triangle wrong? did you just draw your reference triangle in quadrant 1, but all your trig functions were correct for the triangle you had drawn, then I would have taken 1 point off. Some people had the reference triangle wrong, and then somehow they got their sine and their cosines backwards as well, and so that would miss 2 points, and so on. Okay, number 6. Sine times cotangent equals cosine. Again, it would be very easy just to divide both sides by sine. You get cotangent equals cosine over sine, and clearly that's correct, but you're not allowed to do that, right? Okay, you can't divide stuff, move stuff. You got to just pick one side and only simplify that one side. So which side are we clearly going to simplify here? The left. So using a quotient identity, you can rewrite cotangent as cosine over sine. Then by the rule of multiplying fractions, this becomes sine x times cosine x over 1 times sine x. Okay, and then technically by the commutative property and the associative property of multiplication, these signs cancel, right? Canceling is not a mathematical rule. You do realize that this whole idea of canceling is a combination of all these other algebraic properties you learned in Algebra 1, like commutative property and associative property, so that you can divide before multiplying. And so you end up with cosine equals cosine, which was correct. Agreed? So that one is pretty good. Number 7, secant, if we use the reciprocal identity, is 1 over cosine, divided by tangent, which by the quotient identity is sine over cosine. Dividing fractions is the same as multiplying by the reciprocal. Multiply these fractions, you get 1 times cosine over cosine times sine. The cosines cancel, you get 1 over sine, which by the reciprocal identity is cosecant. Woo, woo, woo. Agreed?
Yes.
Okay. And then number, a lot of people got really close to answering number 8, and it was not your knowledge of the trig identities that messed you up. It was your complete failure to remember how to subtract fractions. When you subtract fractions, do the denominators cancel away? No. If you have 5 apples minus 3 apples, what do you have? 2. They're still apples. Just because you're subtracting doesn't mean the apples subtract and cancel each other away. Now you have 2 undefined objects, 2 atoms or molar, I don't know, right? 2 just generic anythings, right? So secant is 1 over cosine. So we can call secant 1 over cosine x. Tangent is sine over cosine. So you're going to have sine x over cosine x times sine x. Of which sine x over cosine x times sine x is a sine squared x over cosine x. In order to subtract fractions, you have to have what? A common denominator, which we have. But when you actually subtract fractions, you subtract the numerator, that's your new numerator, but the denominator stays the same. A lot of people just wrote 1 minus sine squared x and that's it. It's still over top of a cosine x. Now what is 1 minus sine squared x? By the Pythagorean identity, it is cosine squared x. Whenever you divide something squared by something, they cancel, you end up with cosine. Cosine is the reciprocal of secant, and that's it. Okay, so not too bad actually, right? A lot of people got 25 out of 24 on this quiz.